Okay, I'm going to assume you did that, and I guess I will start. Okay, so I guess we'll make a little graph, and we will put little tick marks. Yeah, that's about right. So each one will represent 1, each hash mark. So with our funky looking rave graph, we're going to sketch the curve. So I guess we will first, well, I guess we could look at some memorable points first. So 2, -1, 0, 1, 2. I did say not to do this, but I'm only going to do it for 0, so I don't even know why I did this part. So let's just put it in for 0. 0 cubed is 0 minus 0, and that's just 1. So I actually don't know why I did this whole thing, but we're just only going to plug in this. Because, yeah. Why not? So that's 0, 1. Just because I always like to go for 1, because it just seems simple. And of course we're not going to plug in every single one, because that'd take way too much time, and we can miss a critical point, which wouldn't be good. But for this one, you probably could have done this and gotten away with it. But that is not what you're supposed to learn. So y prime is 3x squared minus 3. Now this equals, if we factor it out, is 3x squared minus 1. See? Same thing. Okay, so how are we going to make this equal to 0? Because we're looking for critical points right now. And possible undefined points, but doesn't look like there's going to be because it's not a fraction. So, and no negative exponents. So it doesn't look like there are going to be any undefined points. So we'll set that equal to 0. And to make this true, it has to be x plus 1 or minus 1. Because minus 1 squared is just 1 minus 0, which is 0 times 3, which is 0. Same thing with 1. So we know where our critical points are. It's at 1 and -1. Okay, so now we just have to find the y. So now we just have to calculate 1 plus 1 and minus 1 for y. So if we plug in 1 cubed is 1 minus 3, that's -2, and that's -1. So 1 is 1, -1. And for -1, it's -1 plus 3, so that's 2, and that's 3. So 1, 2, 3. Okay. So I'm going to do what, I guess I'm skipping a step, but hopefully you can see why I'm doing it. Y prime, or second derivative, is 6x. Because derivative of this is just 6x, because this is a constant. So if you know how inflection points work, if wherever where y prime equals 0, that's an inflection point. How I think of inflection points is kind of like it's more abstract, I guess. It's kind of like, imagine this as a curve, and this is kind of like the point, this really large point, that's kind of like switching from positive to negative. How at least I think of it. So that means that x equals 0. So that means 0, 1 is an inflection point. Because we plug in x equals 0, we get 1. Like we did before. So that means our graph will probably look something like this. Or actually, more like this. Yeah, around that. So there's something we haven't figured out, and that is where it goes off in a direction. Most calculus classes will just stop at this. They'll probably just like, oh, well, like, does that. And I kind of spoiled it, but they'll probably just finish it for you. They'll probably just like only show you the critical points. But that's really not how it's supposed to work. So what we have to do is find the ends, which is basically the farthest it can go in this direction and the farthest it can go in this direction, which is infinity plus infinity over here and negative infinity over here, at least theoretically. So algebraically, it's the ends are x plus minus infinity. And I'm going to pick another color. Yeah. So now we have to find y, which y is, I already know without even looking at it, it has x cubed in it, which is the highest term, minus 3x plus 1. Now, infinity, well, when x approaches infinity, let's say, well, let's do plus infinity for now. Well, when x goes to approaches infinity, that's important, approaches infinity, well, then this is growing exponentially faster than these over here. Infinity cubed is growing much faster than minus 3x cubed. Much faster. That's how I listen. Maybe I should do it like this. Well, as x approaches plus infinity, y approaches plus infinity as well, because infinity squared is just infinity. So hopefully I didn't have to dwell too much in that. But so as x goes in this direction, in this direction, y goes in this direction forever. Now we have to do it for the other one, and hopefully you can catch my drift. You don't need another color. Okay, so x approaches negative infinity, and like we said, x grows, x cubed goes exponentially faster. So minus infinity cubed is just going to be negative infinity again. So this is going to go in this direction as x goes infinitely to this direction, or negative infinity. So our graph kind of looks like this. My drawing may, if you actually draw this on your own, it may look very different just because I'm still trying to get used to this setup I have. So sorry if it looks a bit wonky. Hope you enjoyed, and it's below 10 minutes. Look at that.